Hi there. In this video, you will learn how to use ELVA 1 Lab Bench for signal attenuation and wireless link analysis in a university lab. Operating in the FCC lightly licensed 71 to 86 GHz frequency band, this training system provides a unique educational platform for students studying wireless communication, digital signal processing, and millimetre-wave technologies. This video was recorded in ELVA 1 R&D lab. The proposed system includes two transceivers operating in the E-band. This band is divided into two frequency ranges, 71 to 76 GHz, lower band, and 81 to 86 GHz, upper band. One transceiver is set to 85 GHz and the other to 75 GHz, with receiver frequencies automatically adjusted. The duplex separation is fixed at 10 GHz. The transceivers are connected via a waveguide channel with two fixed waveguide attenuators for signal control, one electronically tunable attenuator for dynamic attenuation adjustment. A control unit with a keyboard and USB interface enables automatic attenuation control via the integrated software package included with the system. The training system software enables traffic processing and visualization of various radio channel parameters at all stages of signal encoding and decoding. Each transceiver's modem is equipped with a dedicated signal processor, capable of generating synthetic traffic based on a pseudorandom sequence and running a traffic analyzer without the need for external testing instruments. Additionally, the processor provides comprehensive radio channel diagnostics, a key feature utilized in this laboratory exercise. At present, the system is set to 128 QAM modulation. On the right side of the screen, the Reed-Solomon decoder stress factor is displayed, while the middle column shows the bit error rate, BER. The center of the screen provides an overview of the radio channel, including parameters such as signal-to-noise ratio, SNR, phase noise, frequency offset, and phase deviation. The current modulation scheme in the communication channel is also displayed. Users can manually switch the modulation profile, which dynamically updates both the modulation type and the constellation diagram on the left side of the screen. Changes in the modulation profile automatically affect all signal parameters. As part of this laboratory exercise, students can explore key digital communication channel parameters. By adjusting the tunable attenuator, they can observe and record the relationship between BER and SNR, comparing experimental results with theoretical calculations displayed on the screen. By using this training bench, students can develop a deeper understanding of signal attenuation, modulation schemes, and error correction, gaining hands-on experience essential for mastering high-frequency wireless communication systems. Thank you for watching.